Hello everyone and welcome to this video. Today I will show you how can link or how can integrate the virtual reality with ROS to make a more immersive simulation. So okay, first of all we need this program, we need this software. In this case we are using Blender is a 3D engine. Okay, we use this Blender, and the next step is transfer the STEP file, this one, to a collide model, to collide architecture. So how can do that? First we go to Onshape, and in Onshape just very simple, go to import, and we're looking for these MyCobot steps, create a composite, combine and import. So before I have imported this file because this process could take a bit of time. So when we have been import in Onshape, so the next step is export to a collider. Okay, in this case I have been exported this one. So now go to Blender, and Blender import collider, download, and that's all. So now why is necessary you do or make this process? Basically because we need to create our environment, we need to define the different joints. Since in the previous video we used the URDEF import that automatically create the joints, automatically create the green object, but in the virtual reality, as is programming, you create an APK for Android. The URDEF imported doesn't compatible with this architecture. So for this reason, it's necessary to create our model, or create our the different joints. So okay, now first we need to divide our robot into the different links. So we have 1 link, 2 link, 3, 4, 5, 6. This is the base, just only Control J. If we have this error, activate object is not mesh, we click, right click, mark as asset, and then repeat. Okay, Control J, and we have our object. So now modify the name, G base, and repeat the same process with the other links. With this one, Control J, change the name, link 1, repeat with the other, oops, Control J, repeat with the other, okay, this is the, I forgot to change the name, this is the link 2, this is the link 3, this is the link 4, now rotate our model, This is the link 5. And the last one is this, link 6. Okay, the other things we don't need it, so just select all and remove. Okay, now Control S to save our model. This is my Cobot 280. Okay, so the next step is really important because we need to define the different arc rotation axes. To do that, first we need to select the object. Then we click the key tab and tap, or simple move to edit mode. In the edit mode we can see the different mesh. So to be more easier, the definition of to select the different mesh that we need to organize or to know the center of our model, we can now go to here and select model, and just only need to select the different triangles. Okay, when you finish to select these triangles, just only go Shift S and select the move the cursor to the selected. So we can see that the cursor of our model moved to the center of the selection. So now go to again to the object, and now right click and set origin to the origin of the cursor. Okay, and we can see that the origin is putting on in this position. Okay, so the next step is we make visible the next link and repeat the same process. Select, pass to edit mode, selection, the different triangles, Shift S, cursor selected, come back again to the object, right click, move set origin to the 3D cursor, and that's all. Okay, now with the link 2, and repeat. Okay, Shift S. Okay, object, right click. Okay, the next one is the link 3. Continue. Shift S. Okay, object, right click, set origin to the 3D cursor, repeat to the another now top. Okay, Shift S. Okay, click, set origin, the last one, edit mode, move Shift S, okay, set origin, and the last one finally. Okay, in this case we select this one, all of these triangles, okay, Shift S and object, right click, set origin to the 3D cursor. Okay, it's done. We clear this and we clear this, clear asset, clear asset. So now the next step is create the relationship between each of these joints, because the idea is create that chains that if I move this joint, all the different links move at the same time. So how can do that? So the next is, first we need to do to the father to the child. We select the child to the father. Okay, the child and the father. Control P and object, and we can see in the set collection that the base is the father and the link 1 is the child. So continue with the same, repeat the same process. Link 2, link 3, link 1, sorry. Control P, object, and we had an error here because maybe select another two, just only Control C. Okay, this is the link 2, this one to this one. Control P and object. Okay, so father and child. Next one, repeat this one with this one, object, continue, sorry, this one with this one, and this one with this one, and object. Okay, done. So if we select this object, this case this gain object, so now we can see that move, but the rotation is not a good rotation because it starts to rotate in this position. So we can move here, but okay, so we can see that rotate in the bad way. Okay, but all the joints are being linked. Okay, so next, Control S. The next is export to FBX. When we can export to our Unity project. So Before to export, we need to create a new project. In this case, we'll call it ROS2 OBR UV1. Okay, we create, oh my god. Okay, now we need to create a new project, modify, we change the version of Unity, change the name, ROS2 virtual reality, call it UV1, and now create a project. Okay, it's done. Now repeat the same process of the last video. It's okay. Now here go to create folder. In this case, call it gain object. Gain object. This we create a new folder called models. And in this folder we're going to export our FBX model. Okay, good. So Control S and close Blender. Now we're going to remember, just only need to install this package in Unity. The another one doesn't work. So remember, go to Package Manager, Windows Package Manager, add package for URL, add, and it's okay. Now reopening our project to fix this error. Now go here. Okay, so next step, going to File, Build Settings, select Android, switch platform. Okay, because we need to start to compile for the virtual reality headset. Okay, good. Now go here, add OpenSN, add this SN. So now we continue with the second part. So we now, the idea, remember, is to make the simulation in our virtual reality headset. Okay, so now first of all we need to install the different package that we need to use to make the simulation using the virtual reality. So first of all we go to the package manager, Unity register, and we need to install the XR. We need to start the XR plugin, installs. We need to start the interaction toolkit and XR hand. Install interaction toolkit. Okay, yes. Okay, now to XR. Okay, done. Come back to the package manager. Unit register, XR hands. If we want to use hand interaction, okay. Okay, this example we will use this headset. In this case is the Pico 4. This is the Pico 4 headset. It's a virtual reality glasses. This is different to the MetaQuest 3 or MetaQuest 2 or 3S. Okay, so first of all, we need to install the package or the SDK that is necessary to integrate the Unity with this Pico 4. So now we download this zip file. And then go to downloads. Okay, it's downloaded. The Pico 4 integration SDK, extract here. Okay, Control X, go to my other hard disks. Here, this is an old SDK. Okay, so now to install this package, just only go to the plus, add package from a disk, another location, Pico 4 SDK, and this is the last one, and click in package JSON. Open it, and we need to wait to install the library. Okay, now it's done. So maybe we have an error that it's necessary to fix it. Project. Here we need to select with headset we want to use. In this case, Pico 4, add feature. Show all, fix. Okay, it's fixed. If we maybe don't have the headset, it's possible activate the simulation in the simulator in the scene. We click and it's done. In this case, we activate when we hit play. The simulator start to run if we don't have the headset. Okay, so now click clear, and that's okay. We have a new menu. This case is the SDK. We have an access token if we want to publish our app. Platform settings, apply, and okay, now go to 3D object, create a new plane 0 0. Okay, to be more easier and more faster this video and more short, we use an example of an XR. So we need to come back to Windows Package Manager and select each of this library or each of this package, and then go to the samples and import the examples. Okay. No, okay, import. Okay, this is not necessary. Okay, now go here, fix all again, fix all again, fix all. Fix all, and that's it, hopefully. Fix all, okay, now it's done. Close and close, clear this error, and then go to the samples. We go to this part XR, and we need to find the SN. This is the hand interaction. We click save. This is the hand interaction example. That's really interesting to test, because basically we have an environment, and in this environment we have different elements that we can interact with this object. So okay, copy. I want to use this SEM, so copy the SEM and go for our asset and paste in this folder. Now open again. This is our SEM, and now we start to modify this SEM, maybe adding a new object, in this case a new gain object, that in our case is our robot. Okay, so now go to folder gain objects, and then to the subfolder models, and then drag and drop the robot into the table. Okay, rotate a little bit, perfect. Okay, so now Control S, and then we need to go right click, prefabs, and unpack completely. Now we need to transform this one to a gain object, drag and drop into our gain object folder, and now we need to add the joints that help us to simulate the articulation. We can change the color. We need to modify the materials, but at this moment it's not necessary. So now we click here in add new component, and click and type articulation body. The articulation body is a script, or is a component that helps us to create the articulation in each joint. The first articulation, the first joint, is the base. For this reason, we need to add this in the base of our robot. And this one is this is our base. So now we click remember in a movable, and now we need to add to each link, we need to add the articulation body. Okay, now add articulation body here, add articulation body here, add articulation body here, and add articulation body here. Okay, so now we need to define which kind of articulation joint type. So in the link 1, we need to modify to revolute. In the link 2, repeat again, revolute. In the link 3, revolute. In the link 4, revolute. Link 5, and in the link 6. Okay. Control S to save our project. And now we need to define which axis is that this link or this joint used to rotate. So the first link is this, and it rotates in Y. For the reason, change here to 0 to 19 degrees. Okay, we can do play. And this is our hand simulation. We can see how can move the control, how can move the camera around the system. We can move using the simulation. We can rotate. We can move top, move down. Okay. We can change the control. You see the Y and T. Is in this small window. We can see the combination key to move. Okay. So now, okay, perfect. Okay. So now we need a script to help us to control at this moment using a keyboard to control or R. Yeah. Now the next is the link 2. Link 1, link 2 is in this one. Rotate in the C. Okay, that's okay. Link 3 again, link 4, link 5, and link 6. Okay. So as we can do in the ROS example, in this case we need to do the same, changing this value, stiffness and damping, 10,000 and 1,000. Okay, now we need a script that allows to receive or to subscribe into a ROS2 topic. Okay, welcome to the continue to this video. So the next step is remember, configure the ROS version, ROS 2. In this example, we need to know the IP address, but at this moment don't modify. In the future will be modified. Okay, so we clear. We have this error because the MyCobot interface doesn't install. It means that the ROS message, remember, go to our home, ROS 2 workspace, is our MyCobot description, URDef here. Sorry, it's not here. It's MyCobot here and interface, and open it. Click here and boil. And boil. Okay, now close. The error has been disappeared. Okay, perfect. So now we go to our robot, and we drag and drop script. This script, we need to add the gain object and the different joints. Okay, so now go to link 1, link 2, 3, 4, 5, and we need a span from the link 6. Okay. Perfect. So now go to Control S. In this moment, this example, we use the same IP address, 100, the local host address. Okay, so now execute the checkpoint, the TCP endpoint. So now we execute the TCP endpoint, and now repeat again the ROS 2 MyCobot. Okay, now here hit play, and as can we see, the execution or exists the communication between ROS and Unity. And now we move. Okay, now we start to move our robot, and that's all. That's very simple. Oh, we have a problem here. Basically, it's because the articulation, the joint, it's not in the center of this joint. How can solve this? That's sometimes it's simple to solve, but sometimes no. Okay, so go here. We had two options: to return to Blender and modify the articulation in Blender, or use these tools. This is the base. This is the movable. This is the link 1, and now we can modify this the articulation. Okay, now here link 2. Okay, so I think so that it's more easier if we come back to Blender and modify this error. Okay, so I show you how to modify this error in the next video. Okay, welcome again. So now we try to fix this error that our robot not move the good way. So how can solve this? This is okay. So now we need to move this this pointer. So come back to edit and select we select this. Okay, now click here, okay, Shift S, move to the center. Have a bad, so because it tried to make a mean. Okay, Shift S. It's not good. Okay, now we try to take this one, all of this mesh. Okay. It take a little bit of time to select each triangle. Be patient because it's not an easier task. Okay, finish. Shift S and in the middle. Okay, so now go to object model, right click, set origin in the 3D cursor. Okay, so now the next one is the link 2. We need to select, move to edit mode, select this, Shift S. Oh my god, this need to. Okay, try with this way. Okay. Perfect. So go to the link 3 and repeat the operation. Repeat the last step. Okay, so now go to edit mode. This is the easier way. Shift S. Now this in the center. Oh my god. So click and select it again. and select again Shift S. Okay, more or less. Okay, now right click, set the region to the center of the cursor. Okay, now the next one. Okay, repeat. Okay, right click, cursor, perfect. Now come the last, this. Shift S, Shift S. Okay, right click, and here, and finally the last one. Okay, Shift S, and the cursor, tab. Okay, perfect. Come back, come back, come back, come back, come back, come back, and base. So now, if I rotate, okay, we are rotate all the base. Link one, so we fixed this problem. Oh, okay, now perfect. Okay, now perfect. 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 And the last one, perfect. Okay, fixed the error. So now it's to repeat the step. The first video is export FBX in our Unity project. Well, then ROS to UBR. Here, gain object models and replace. Perfect. Save. Come back for our project. Don't worry, it's totally normal that the model do these things. So now we go again. Move a robot here. Maybe move a little bit and rotate here and change the position here. Perfect. Okay, so now remember, right click prefab, unpack completely, remove the old model and drag and drop the new gain object. So now repeat the process. Articulation body, remember this is an unmovable element. Okay, link 1, revolute 10,000, 1,000, rotating Y, 90, link 2, articulation body, revolute 10,000, 1,000, and this rotate in, okay, fixer revolute 10,000, 1000, and again in 90 degrees. See, okay, repeat, revolute, 10,000, 1000, and this last one is 19 degree here, 0. Okay, wait, no, sorry, 90 degree, 5 here, articulation body, revolute, 1000, 10,000, 1,000. Okay, and this one it's 90, 0, and the last one rotate in X. So articulation body here 90 degrees, 0, revolute, 10,000, 1,000. Okay, so now we test again. Okay, now perfect. Join state. Oh, that's really good. So it's necessary to add the scripts that the robot need to make the communication with ROS2. Drag and drop the script. Okay, now the gain object. Now each link 1, link 2, link 3, link 4, link 5, and the last one, link 6. Ctrl S, play, and move, and that's all. Okay, fix the error. Perfect. So, okay, so at this moment, all the program work in Unity using the simulation, the virtual reality simulator. But now the idea is to transfer this app or this virtual reality model in my headset, in this case in my Pico 4. Okay, so how can you do this process? That's really simple. So first, it's necessary to know the IP address of the in this case of my headset, because remember that Unity ROS use the TCP endpoint to communicate between the ROS and the package in Unity that controls ROS. Okay, so this process I will show you in the next video. Okay, welcome. So we now to start the transmission between my Pico 4 and this browser to show you how is the how can interact with this. So okay, this is important. We need this IP address. This is the 192.168.0. Okay, this IP address is really important because we need to modify. In this case, we need to modify here. Yeah. dot 0 dot 140. That's 0 and 140. Okay, so now copy, and we go to our ROS2 workspace. Here come to ROS TCP, launch, endpoint, and change this address. Okay, so now Control S, come back to our terminal here and clear colcon boil clear. Okay, so now we need to send this our application to our Pico 4 headset. To do that, just only go to build settings and select our device, refresh. Oh, it's necessary to connect the headset to the USB port. Okay, now it's connected and device refresh. This is my Pico and byte and RAM. We can put name a key test. Start to boot it. Okay, so now we need to wait science finish. And that's all. Okay, so now close here, unplug. Okay, now it's that not nice. So goes, come back to here, ROS to Pico 4. We cannot move. This problem happens because we didn't select the headset into the build settings. Basically, we need to go in edit, project settings, and in project settings we need to here, and we had an error here for this reason. Pico 4 support. Okay. Up XR. Okay. XR simulation, no. Open XR. Invalidation, fix all the different errors. Okay, good. Up XR. We don't have any error in Pico XR. Now repeat the process, voice settings. Wait. We need to change because this is an other send. In this case, is the hand. Demo sends. And repeat again. Test APK, okay. Save, replace, and wait the compilation process. Continue compilation. The first times take a bit of time. Come on. Okay. Okay, so now done. establish, enter in the actual area. Okay. This is our app. This is not our app. Okay, remove it. Okay, maybe we have some problem during the compilation. So remove and come back again. Try to execute our application in virtual reality into our Pico 4 headset. Okay, so first of all, we need to know the IP address, in this case, of our machine. If config, okay, this is our IP address. Now copy. And go to into TCP endpoint and pass and compile with code convoy. Now we go to ROS Unity settings and modify this address. Control S. Now we need to connect our headset using the USB-C. This is now USB-C. Where are the USB-C? This one is the USB-C. Connect here. File, boil and run, boil settings and execute. Okay, now this APK and run. Here we execute our ROS2 TCP endpoint. Perfect. So now just only need that compile the Unity project in our headset. Okay. Come here and come back, start transmission. Okay, so use the same cast. That /56 HT. Okay. Allow the transmission. Okay, we start to transmit. We start the transmission. Go to here, open it. Okay, so now come back. Great. So now I go here in ROS. and we execute this script. Okay, so wait a second, because we have an error here, and this error is because my real robot, it doesn't connect. So, but it's solved. Simple. Okay. This video shows a mixing between the virtual reality ROS and a real robot. Okay. Modify the camera. Perfect. So now a bit more smaller here and here. Okay, so now we come back, execute. Okay, join states, and start to move. Okay, we can see that the robot move it into the virtual reality, yes, using the join state in ROS 2. So we can do the same process. It means that we can move our real robot, yeah, and replicate the movement into the virtual reality. Okay, so that's all. I hope so that this video really interesting for us, for you, and thank you for watching.